Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about heterocyclic compounds and polyaromatic compounds. So let us start learning of heterocyclic compound. Heterocyclic compounds are those cyclic compound in which one or more of the ring carbon are replaced by another atom. For example, you can see here. This is the cyclic system and carbon is replaced by nitrogen. Then it becomes pyrrole. Oxygen in place of carbon, then it is called furan. In place of carbon, sulfur is there, then it is known as thiophene. And then fused, this is the indole. Now six-member ring, you can see pyridine, quinoline and isoquinoline. So let us learn one nomenclature here. Always you start numbering from heteroatom. You see oxygen 1 and then 2, 3. So 3 has methyl group, so 3 methyl furan. Here 2 bromo pyridine. Now you can see the alpha and beta position. Thiophene, sulfur and nearby carbon is alpha and after that carbon is known as beta. So C in thiophene alpha and beta, pyridine alpha, beta and gamma. So nomenclature is alpha methyl pyridine and 2 methyl pyridine. Now let us learn about the pyrrole, which is the 5-member ring. So first patient, you can see pyrrole may be obtained from acetylene. You can see 2 molecule acetylene and ammonia, you will get the pyrrole. This is the one synthetic method. Another synthesis method from ammonium mucate in presence of glycerol on heating, you will get the mucus acid. And after dehydration, you will get the pyrrole. Now another also methods reported in the literature, succinimide. From succinimide, you will get this product and this product undergoes zinc reactions, you will get the pyrrole. So you have to remember 2 and 3 reactions for the preparation of pyrrole. We have another succinic dialdehyde, you will get the pyrrole. Furan react with the ammonia, you will get the pyrroles. So you have to remember only 2 and 3. Now structure of pyrroles. You can see the structure of pyrrole. Here sp2 sp2 sigma bond, sp2 s sigma bond and sp2 sp2 sigma bond. You know there is a double bonds. So unhapped sp orbital, you can see the lone pair on nitrogens. That's why this is the pi molecular orbital delocalized and it follow the Haeckel's rule. It is cyclic, follow the alternate double bonds. So it follow the Haeckel's rule. So this is the aromatic compound. Now you can see the pyrrole resonating structure. Now basic properties. Because pyrrole is basic, automatically it react with acid and form this salt. So if this compound shows that and this reaction shows that the pyrrole has the basic properties. Now acidic properties, you can see this hydrogen is easily replaced with the OH minus and forming this pyrrolyl potassium. This reaction indicating pyrrole is acidic nature also. So this is the resonating structure of. Now electrophilic substitution. You can see attack at carbon 2 more stable 3 resonating structure here forming when electrophile approaches at position 2. At position 3 you can see only 2 which is less stable. So nitration occurs at 2 position to nitropyrrole You can see here, this is the mechanism how NO2 plus approaching at two positions. It is resonance stabilized, and final step you will get the 2-nitropyrrole. You know the sulfonations. In presence of pyridine, you will get sulfone pyrrole 2 sulfonic acid. Halogenation, thionyl chloride, it will give the 2, 3, 4, 5 tetra chloropyrroles, 2, 3, 4, 5 tetra iodopyrroles. Friedel-Crafts acylation, you know, pyrrole react with the acetic anhydride, it gives to acetyl pyrrole. Kolbe-Smith carboxylations, it gave the pyrrole 2 carboxylic acid. Riemann-Tiemann formylation, it gave the pyrrole 2 aldehyde. Diazo coupling reactions with pyrrole, you will get the 2-phenyl azopyroles. On oxidation, you will get the malicinamide. On reduction, you will get the 2 product 3-pyrroline and pyrrolidine. Ring expansion reactions, starting from pyrrole, you will get the pyridine. Ring opening reactions, you can see the pyrrole undergo reaction with the hydroxylamine. In presence of ethanol, you will get the succin dialdoxymes. Now furan and its derivative. This is the structure of furan. One carbon of the cyclic system replaced by oxygens. Now pipation, you can see mucius acid undergo dry distillation. You will get first furic acid and finally you will get the furan after decarboxylation. For fural, on oxidation give furoic acid, then on heating you will get the furan after decarboxylation. For fural, directly react with the silver oxide, you will get the furan. Succin dialdehyde, you know it give dienodiol, which on reaction with the P2O5 under heating you will get the furan. So this is the structure of furan, and here also same bonding scheme like pyrrole. Anhydride p orbital and other oxygen lone pair of electrons. You can see the pi molecular orbital in the ring. This is a resonating form of pyrrole. Now again, like pyrrole, it is also basic character. So furan react with HCl, it gave 2 products. One here this salt, and this salt undergo O2 polymerization, give brown resin, and furan hydrochlorides further react with the water forming this dialdehyde compound. Now electrophilic substitution reactions like pyrrole, it also gave the 2 position more substituted and more favorable than 3. So nitration gave the furan 2 nitrofuran. Sulfonation, you will get the furan 2 sulfonic acid. On halogenation, you will get the 2 bromofuran and 2,5-dichlorofuran, 2 chlorofuran. On BF3, Friedel-Crafts acylation with acetic anhydride, you will get the 2-acetylfuran. It undergo reaction with mercury chloride, you will get the 2 chloromercury furans. And then mercury chloride undergo reaction with acetyl chloride, you will get the acetylfuran. Reaction with N-butyl lithium, you will get the 2-furan lithium, and further 2-furan lithium react with carbon dioxide and HCl, furoic acid will form. You know, diazo coupling furan is not sufficiently reactive to couple with the diazonium, benzene diazonium chloride. On reductions of furan, you will get tetrahydrofuran. Ring expansion, you will get diacetyl. Ring opening, you will get diacetyl of succinyldialdehyde. And reaction with malic anhydride, you can see furan react with malic anhydride, it gives Diels-Alder products. So, 2 pipation and all properties, you should write it down in your notebook and practice it for the exams. See the thiophene. Now, pipation of thiophene, you can see 2 molecule acetylene react with H2 in presence of aluminum oxide, you will get the thiophene. You can also synthesize thiophene from sodium succinate. It will also form from furic acid. And N-butane undergo reaction with FOLS at 650 degrees Celsius, you will get the thiophene. Now you can see the structure of thiophene, resonating structure and molecular orbital diagrams. Now properties, chemical properties, you know, it undergo electrophilic substitution reactions like pyrrole and furan. Thiophene also give reactions with nitration and it will form 2-nitrothiophene. Sulfonations, sulfonations, you will get the thiophene 2-sulfonic acid. Halogenation, you will get the 2-chlorothiophene. Brominations, you will get 2-bromothiophene. And on iodinations, you will get the 2-iodothiophene. Friedel-Crafts acylation, thiophene react with acetic anhydride, it gives 2-acetyl-thiophene. Chloromethylations, thiophene undergo formaldehyde and HCl reaction, you will get the 2-chloromethyl-thiophene. Mercuriations, it gives 2-chloromercury thiophenes. N-butyl lithium, it gives 2-thiophene lithium, and further 2-thiophene lithium undergo react with the carbon dioxide in acidic condition, you will get the thiophene 2-carboxylic acid. Again, diisocoupling reaction is not suitable for the this thiophene. Now reductions, thiophene undergo reduction, it gives the tetrahydrothiophene. So my friends, you can see the reactions of diindiol and derivatives of thiophene. So now 6-member ring, this is also very important, pyridine. You know, pyridine is also very important heterocyclic compound. How you will prepare pyridine? Pyridine can be prepared to 3 molecules of acetylene. You can see here. From piperidine, you will get the pyridine. From pyrrole and dichloromethane, you will get the pyridine. From beta-picoline, you will get the pyridine. You can see the reaction scheme. Glutatonic aldehyde, you will get the this unstable compounds, and then finally you will get the pyridine. So a lot of methods, you have to focus on at least 5. Tetrahydroporphyryl alcohol, you will get the pyridine. 2 molecules acetylene undergo ammonia, it gives the pyridine. Now structure of pyridine, you can see this is the structure of pyridine. Again, here is the sp2 sigma bonds. Here unhybridized p orbitals. You can see the lone pair of electron is not taking part in the delocalizations. So lone pair is there. This is the resonating form of pyridine. Now properties, you know, basic character of pyridine. How you will prove? Because it reacts with HCl, it gives pyridinium chloride. You can see lone pair in sp2 orbital and lone pair in sp3 orbitals. So pyridine is less basic and this is the more basic. Now electrophilic substitution, you can see pyridinium cation formations. So attack at carbon 3, it gives more stable, but attack at carbon 2, you will get the less stable, even attack at less stable. So 3 position is more important for electrophilic substitution. So nitrations, you will get the 3-nitropyridine. On sulfonation of pyridine, you will get the pyridine 2-sulfonic acid. On bromination, you will get the 3-bromopyridine and 3,5-dibromopyridine. Friedel-Crafts reaction, you can see it will not go give the Friedel-Crafts reaction because formation of this pyridine aluminum complex. Now nucleophilic substitutions, you can see if you attack at 2, you will get the more stable this resonating form. Attack at 4, you will get one unstable. This is the also attack 3 less stable. So mostly nucleophilic attack at position 2. See the Chichi-Bevin reaction, pyridine gave the 2-aminopyridine. This is the mechanisms. Reaction with sodium hydroxide, you will get the 2-hydroxypyridine, pyridol. Now you can see pyridine react with the base, give 2-hydroxypyridine, pyridol and 2-pyridol. Reaction with N-butyl lithium, it gave 2N-butylpyridine. This is the mechanisms. On oxidation, you will get the pyridine N oxide. On reduction, piperidine. Reaction with alkyl halide, you will get the N-methylpyridine neum bromide, and a lot of uses. Now you can see the quinoline structure. Quinoline, pyridine plus benzene. So one method of preparations, very important. So method of preparation, you can see how you will prepare this quinoline. So aniline react with glycerol under these acidic conditions, you will get the quinoline. This is the mechanisms. First you learn about the synthesis, then mechanism in fourth steps. And another methods of synthesis, Friedlander synthesis. Friedlander synthesis starting from orthoamino benzaldehyde and acetaldehyde, you will get the quinoline. So one method of preparation is necessary for third part of history. Now structure of quinoline, you can see quinoline structure. Now properties, again basic character, it react with the acid, it gave quinolinium chloride. Electrophilic substitution, nitration occurs at 5 and 8 position. Sulfonation occurs at 5 and 8 positions. Reaction with sodamide, it gives 2-aminoquinoline, which is Chichibibin reactions. Reaction with potassium hydroxide, you will get the 2-hydroxyquinoline. Reaction with N-butyl lithium, you will get 2-N-butyl quinoline. On oxidation, quinoline gives quinoline N-oxide. If this reaction occurs at KMnO4, in presence of KNO4, you will get the pyridine 2,3-dicarboxylic acid. On reductions, you will get the 2,3,4 tetrahydroquinoline and decahydroquinoline. Reaction with alkyl halides, you will get the N-methylquinoline iodide. Now see the structure of isoquinoline. Only position of nitrogen change, but numbering should start from the same as like quinoline. So this is the synthesis. You can synthesize from cinnamaldehyde, you will get the isoquinoline. You can see this starting from phenylethylamine, you will get the isoquinoline. Now properties, again it is also acidic and basic reactions. So isoquinoline act as base, it react with the HCl and forming salts. It react with the KMnO4, it give pyridine 3,4-dicarboxylic acid. So this is the part of heterocyclic compound. Now fuse polynuclear aromatic hydrocarbon. You can see the naphthalene, anthracene and phenanthrene. I will show you only 2 and 3 reactions for your exams. Naphthalene, do the nomenclature like that, just like here position 1, bromine is present, so 1-bromo naphthalene. Now structure of naphthalene, you can see here alternate double bonds, it is aromatic in nature. You can see also here how sandwich compounds, you can see up level electron density. So this is the pi molecular orbital. This is resonating structure, it is exist in 3 form, A, B and C. Now synthesis of naphthalene, you can see from you can synthesize this naphthalene from petroleum fractions, from 4-phenyl 1-butene, from phenyl 2-butanoic acid. You can see from Howard synthesis, this is important. From benzene and succinic aldehyde, it gave beta-benzoyl propionic acid. In step 2, beta-propionic acid converted into gamma-phenyl butyric acid, and you will get the tetralone, and finally tetraline, and then tetraline undergo selenium reaction, you will get the naphthalene. Now properties of naphthalene. Electrophilic substitution reaction, you can see this attack at carbon 1, attack at carbon 2. So attack 1 is more stable because it is stabilized by resonance, these two structure. So nitration, you will get the 1-nitronaphthalene. You can see these mechanisms. Sulfonation, you will get the 1 naphthalene sulfonic acid, but if you increase the temperature in presence of sulfuric acid, you will get the 2 naphthalene sulfonic acid. Halogenation, you will get the 1 chloronaphthalene. You can see there are one addition product, and then further it gave the 1 chloronaphthalene. Friedel-Crafts acylation, you will get the 1 acetyl naphthalene. You can see 2 acetyl naphthalene in different reagent. Friedel-Crafts alkylations, you will get the 2 ethyl naphthalene. Chloroformylations, you will get the 1 chloromethyl naphthalene. So naphthalene, it gave the tetraline on reductions and 1,4-diolenes if react with sodium and ethanol. Naphthalene undergo complete reduction, you will get the decaline, and this is the cis-decaline and trans-decaline. On oxidation, naphthalene gave 1,4-naphthaquinone. Naphthalene react with air, vanadium pentoxide, you will get the phthalic anhydride. In the same way, how you will determine the structure of naphthalene? You know, elemental analysis and molecular weight determination shows that molecular formula of naphthalene C10H8. Dipole moment of naphthalene is 0, and this indicates the naphthalene molecule is symmetrical. Now, you can see here oxidation of naphthalene with oxygen and vanadium pentoxide at 470 degrees Celsius yield phthalic anhydride, and this indicates the presence of benzene ring with 2 ortho side chain in the molecule. So this is the skeleton. Now you can see the nitration. Naphthalene undergo nitration, it gives 1 nitronaphthalene and 3 nitronaphthalene. You can see it react with 10 HCl, you will get the 1 aminonaphthalene and phthalic acid. So electrophilic nitro groups stabilize the benzene ring to which it is called attached ring B, and the other benzene ring is preferentially oxidized. On the other hand, the nucleophilic amino groups makes the benzene ring to which it is attached more susceptible to oxidation, and these results clearly indicate that naphthalene consists of 2 fused benzene rings. So they confirm that naphthalene contains 2 benzene rings. Now anthracene, you know this is the structure of anthracene. If position you can check 9 bromo, because bromine is present at 9 position, that's why it is called 9 bromo anthracene, and 1 anthracene sulfonic acid. Now structure of anthracene as it is, you can see, you can arrange and delocalize molecular orbitals here, and 4 resonating form of anthracene. Again, how you will synthesize the anthracene from Friedel-Crafts reactions? You can see benzene react with acetylene tetrabromide, you will get the anthracene. Another method, benzene, 2 molecules, dibromomethane, it gave 9,10 dihydroanthracene and finally anthracene. Howard synthesis, phthalic anhydride react with benzene, it gave orthobenzoyl benzoic acid, react with sulfuric acid, you will get anthracene. Elb's reactions, you will get the anthracene from methyl benzophenone. Diels-Alder reactions, you can see 1,4-naphthaquinone react with 1,3-butadiene, it gives Diels-Alder products, and which is on oxidation you will get the 9,10-anthraquinone, and on distillation with the zinc you will get the anthracene. Now properties of anthracene, you can see attack at carbon 2, attack at 9. So 9 is more comfortable in comparison to C2, because here benzene ring and aromaticity have no problems. So substituted products and addition products, both products is possible. Now look at the reactions. Anthracene gives 9,10 disodio anthracene deep blue, and this product react with the diethyl chloride, you will get 9,10 diethyl anthracene. Reaction with halogen, you will get the first addition product, then substituted product 9-chloroanthracene. Now Friedel graph acylations, you can see it react with acetyl chloride, you will get the acetyl 9-acetyl anthracene. Nitration, you will get 9-nitroanthracene and 9,10 dinitroanthracene. Anthracene react with sulfuric acid, it gives 1 anthracene sulfonic acid and 2 anthracene sulfonic acid. On reductions, you will get the 9,10 dihydroanthracene. This is the reduced products. On oxidation, it gives anthraquinones. You can see the 9,10 anthraquinone. On Diels-Alder reactions, you will get anthracene react with malic anhydride, Diels-Alder. Now you know the uses. In the same way, phenanthrene. You can see this is the phenanthrene structure. This is the molecular orbital diagrams. These 5 resonating form of anthracene. Now how we will synthesize anthracene? Synthesis of phenanthrene from naphthalene. You can see phenanthrene. In the same way, chemical properties, phenanthrene undergo chlorination, it gives 9,10 dihydro, 9,10 dihydrophenanthrene, dichloro dihydrophenanthrene, and then substituted products. Friedel graph reaction, it gives 9-acetylphenanthrene. On nitration, it gives 9-nitrophenanthrene. On sulfonation, it will give 2-phenanthrene sulfonic acid and 3-phenanthrene sulfonic acid. On reduction, with amyl alcohol C5H11OH 9,10 dihydrophenanthrene. On oxidations, you will get this product 9,10 phentraquinone, and on further reaction with peroxide diphenic acid. So my friends, I hope this video will be helpful to you for your exams. If you like this video, then subscribe my channel, and thanks for watching.